Hello and welcome to SudoKanard. We're here to solve this pirate Sudoku that was created by Christoph Seeliger for the German Championship, the qualifying round. And it's a very unusual variant of Sudoku. It's the first time I've seen that, and I didn't solve it during the contest. It's the only one I didn't have the time to solve, but I solved it afterwards, and it was a really a great pleasure. Not that easy, but really beautiful. So the special rule is that whenever you see the 5, it can only be surrounded on the horizontal and vertical sides by 1, 2, 3, 4. It can't be, it can't have 6, 7, 8, or 9 as a neighbor. So that's a very peculiar rule. And if you see the central box, you see that 5 can only be here. It can't be next to 6, 7, 8, 9. So here we have a 1, 2, 3, 4 triple, but knowing that there's a 1 here, those are from 2, 3, and 4, and those are from 1, 3, and 4. And in particular, 1 is on this side, 2 is on this side. So that's a place to start. And then I'm thinking those 6s say that there is a 6 here, which is interesting because we know that 5 won't be in those cells. And perhaps I can use the fact that I'm solving this on pen-pal and use some coloring. Coloring to just see where 5 can obviously not go. So let's use perhaps purple, and let's use green for where 5 will go, so we know for sure that on the rest of those row and column 5 will never go. On those given digits, definitely 5 will never go. And next to big digits, we know that we won't find a 5. So neighboring cells here of big digits are forbidden places for 5. And I think that's it. No, we know that there is a 6 here, so the neighboring cell can't have a 5. And now I'm seeing that in this box, 5 will necessarily be here, so we won't have a 5 here, and then there will be a 5 in here, so there won't be a 5 in here, and 5 will be somewhere in here. So let's get back to Sudoku. So I know that 5 will be in one of those two and one of those two. And somewhere here. And oh, that's a 5. That's a very inconspicuous 5 here. And we will have a 5 somewhere in here. So let's get back to coloring. This is a real 5. We don't have 5s in there. And for the time being, I think that's it. So let's get back to Sudoku. And so how do we continue? So we know that one of those two cells contains a 5, and this 5 will be surrounded by 2 small digits horizontally, and 2 and 4 are not available. So we have 1 and 3 here, or 1 and 3 here. So in both instances of this logic, 1 or 3 is in here, which makes a 1, 3, 4 triple in this column. So the remaining cells here must be 5, no, not 5, sorry, 7, 8, and 9. And this is not a 9 just because of this. So that this is now a big digit, so we can go back to coloring and say that these are not cells for 5. 5 will be along those cells, so either here or there. And because of that, we can eliminate those cells as well. So now we know there is a 5 down there, so this is not 5. And we're left with a small number of possibilities. for the positions of 5. So here something similar is happening, namely that 5 must be surrounded by small digits. And by the way, this is, oh no, this or that is also a small digit. We don't know which one yet. So here on this row, if 5 is here, then it is surrounded by, so if 5 is here, it's surrounded by 2 and 4. So this is definitely a possibility with 1 or 4 in this position. Or else 5 is here, and this is also 2 or 4. So in both scenarios, those digits are from 2, 4, and 5. And something else of interest is that in this column, 5 will be surrounded by 2 small digits, but we see that already 3 of them have been placed. So the remaining 5 will be next to one of them, which means 5 here wouldn't work. We would need 2 small digits surrounding this 5, and we don't have 2 digits available. So this is not 5, and on this column now, 5 can only be here, and this has to be a 4. So this is a 5, and those are not 5s. Nine is not here. This 9 also is not here. So we get this 9 just by the rules of Sudoku. We get a 6, 7, 8, triple, and 6 is not here. And next to this 5, we have a small digit from 2, 3, and 4. So here we have the same logic as the one I applied here, namely that if 5 is here, then this is 1 or 3. Or 5 is here, so this is from 1, 3, 4, 5, sorry. And if 5 is here, then this has to be from 1 and 3. So this is also from 1, 3, 5. So this here is surrounded by small digits. So this is a small digit. This is from 2, 3, 4. And we already know that there is a 2 in here, so that's a 2. And we actually have a triple here. And 6, 7, and 9 remain to be placed in this row. That's here is not a 9. So this 5 is still surrounded by small digits. So this is 2 or 3. This is also a small digit. Could be a 1 actually. And this is from 2, 3, and 4 because of this one. And because one of them is a 5, this also has to be a small digit. So, and whichever of them is the 5 will need to have a small digit at its bottom. So the remaining 2 or 3 must be either here or there, which means that this is a big digit, namely 6 or 9. And I should probably use different colors for small digits and big digits. I'm thinking that this is what Simon would do, but well, whatever. So we still need a small digit somewhere here. And only one of them, because we already have 3 of them. So here we have a small digit and a big digit. So that's a total, well, just consider that we need a 4th small digit on this row. So that's the 4th small digit, and it must be from 2, 3, and 4. So we have 1 more small digit in here, plus a 7 or 8. That's correct. 6 and 9 are not here, they are not up there. So this is a 6-9 pair. So that's the 6th, sorry. Yes, that's the 6, and that's a 9. And here we get this 7. So it's important to remember to do some Sudoku. And this 6 here removes this 6, and that's a 6, and this disambiguates something. We can't have the 5 next to the 6, so that's a 5. That's not 5, that's a 5. Let's do some more coloring. And let's get back to Sudoku. So this is a small digit, neither 2 nor 3. So this is 1 or 5. Here and there we have small digits. This can only be a 4. So no 4 in here. This is a 2-5 pair. And this is from 1 and 3. And here we 1 and 3, I said. That's not a 4 anymore. We must have a 7 and a 9 up there with a digit from 1, 2, and 3. But let's move on to this 5, which is surrounded by 1 and 3. And here this is a small digit, so I'll leave it with all those pencil marks. Nice. So where else do we look? We know that 6 is here. The missing 1 or 4 is somewhere here with the missing 7 or 8. If 5 is here, then this is also from 1 and 4. And I don't see any issue with that. But I'm seeing that this row is missing 7, 8, and 9. And obviously 9 is not here because of this. This is not 8 because of this. And this is, well, it can still be any of them at this point. On this column, we still need the second digit, the counterpart of this. So the second 7 or 9 is here. So this can only be 8. It makes this a 7, this a 9. And we can remove 7 from the options of this cell. So we have a second 7 or 9 here, and the third digit from 1 to 3. And this now has to be a small digit. So it must be from 1 to 3 as well. So we have a digit from 1 to 3 here, and those are from 1 to 3, so 4 is here. And we can remove this 4. So now we have a 2-3 pair here, and that's a 4. That's not 4. That's not 4 either. We have a 1-4 pair here, and the 3 on top with the 1. Oops, sorry about that. That's the 1. Here, this is not 1. We have a 2-3 pair here. And because of this one, the only place we can have a 1 on this row is here, and that's a 4. And there's no 4 in here. Those are from 4, 7, and 8. And I don't see any eliminations in the rest of this. This 3 here removes this option. Those are from 1, 2, 7, and 9. There's a 9 here. So 1, 2, and 7, and still 4 options here. There must be an 8 somewhere and a 6 as well. So where is the next place of interest? Here we have a 2-3 pair, and I'm mostly seeing that because of those ones, this is a 1. And this 6-9 is complemented by this. So in this column, we still need 7, 8, and 9. So this is from 7, 8, 7, 8, 9. This row needs 7, 8, and 6. So this is from 6, 8. And this is also from 6, 8 because of this 7. So that is a 7. Well, there's still some work to do. So there's probably some housekeeping to be done. But I remember that in the end, disambiguating those fives was the hardest part in solving this puzzle. That's something I definitely remember. So let's recall that one of them has to be the missing 2 or 3. And that's interesting because whichever of them is not a 5 can only be a big digit. So this here, saying all those must be 5 or 7, and this here can only be 5 or 6. So is there some Sudoku technique in here? Well, we could have had some typical Sudoku deduction by chains. 7, 5, 5, 6, 6, 8, 8, 7. So you can prove that at least one of them has to be a 7, which is of no value in this context, but that's a nice exercise. So where is the next place to look? So if this is a 5, is that really what I'm looking for? The fact is that I don't remember what logic I used to make the final deduction. I really have no memory of this. So if this is the 5, then this is 2 or 3. And in this case, I still need a 4 somewhere here. And actually, because of this, I do need a 4 somewhere in here. So if 5 is here, then this is 2 or 3. If 5 is here, then this is 2 or 3. So the missing 2 or 3 in this box is somewhere here. And that's interesting because with those cells we have a virtual 1, 2, 3, 5 quadruple. And by that I mean that all 4 digits are in those 5 cells, so that this is none of them. This has to be 7 or 9. This can't ever be a small digit. Oh, and that's very interesting. So let me just rewind. If this is a small digit, no, if this were a small digit, then we would have here 4 digits from 1, 2, 3, and 5, and there would be no small digits available for the remaining 5 in this box. So this is a big digit, and that's not a 7. And the interesting part of this is that this is a big digit, so this can't be a 5. The 5 is here, and that's the other 5. I really had no memory of this. So that's a 2, and that's 3, and that's 2. And well, I just add some coloring to those. And then let's get back to logic. Is there anything more to gain with this? This must be a small digit, and because there's a 3, a 4, and a 2, this has to be a 1. So that's a 3, that's a 2, that's a 1, that's 3, that's 2, that's 1. Here I need a 3 somewhere. So this is a 3, 6, 8 triple. This is from 7, 8. This 2 makes this a 3. That's a 2. This is from 5 and 8. And this row still needs a 2. So this is 2 or 9, this is 2, 7 or 9. I don't think I can do better at this point. This column needs a 1, because of this the 1 can only be here, and this is from 4, 8. This is from 4, 7, 8, I think. That's correct. So this row still needs the 3. It really does. Oh, sorry about that. 3 could still be here. So we are really approaching the trickiest part that I still don't remember. 5 here makes this a 3, this a 4, this a 6, 8, 9, and I don't remember, probably a 3, which works. So what is the final disambiguation? But when I solved it, oh, I'm seeing what it is. I'm seeing what it is. It's an XY wing. So here, whatever this digit here is, one of them here has to be a 5. If this is a 6, then this is a 5. If this is an 8, then this is a 5. And we know that we have either 2 5s here or 2 5s there. So knowing that at least one of them is a 5, both of them must be 5s. And now all treasures have been found. And the rest should be plain Sudoku. So this is a 7. So this is 8. We'll see about surrounding treasures later. Let's first do the Sudoku eliminations. This 8 here gives the 4, the 7, the 8 and the 4, and 8 and 6 at 7. So that's not 6, that's not 8. That's not 7. 5 must be surrounded by small digits, so that's a 2. 3 and 2. This 5 must be surrounding, yeah, that's a 3. So 6 here. 8 and 6 and 3. And this is now 8, and it pushes the 4 downwards. And nothing is happening, so there are two possibilities. Either I made a mistake somewhere, and I wouldn't put it past myself. This is definitely something I would do, but this looks like it's correct. So I probably made a mistake when I prepared the penpa stuff. So let me just check in a moment. So I just show you that's the penpa file I prepared, and you may see, if you're looking closely, that this 2 here is incorrect indeed. This should definitely be a 4. And this is why this didn't trigger, because I put the correct digit into this cell. So does that mean that I would have made the same mistake during the contest? Well, I might have, but I couldn't say with certainty I would have. I did very few mistakes on that day. So anyway, that's a splendid puzzle by Christoph Seeliger, and this is probably my favorite in the set, even though I didn't solve it during the contest. That was a really, really beautiful logic all along the solve. Really, well, definitely my favorite. And it had a lot of competition with all those quadruples, X sums, which are among my all-time favorite variants. So A very, very nice job. Thanks for watching this video and see you soon on SudoKanard.